Hello everyone and welcome. In this video we're going to evaluate the integral from 0 to infinity of the fractional part of x minus 1 half divided by x dx. Okay, let's denote it by I. Okay, so I'm going to recall that the fractional part of x is actually x minus the floor of x, so the integer part of x. Okay, so I'm going to write I as the limit of I sub n, where I sub n is the integral from 1 to n of x minus the floor of x minus 1 half divided by x dx, which can be written as the sum for k going from 1 to n of the integral from k to k plus 1 of x minus integer part of x minus 1 half divided by x dx. Okay, so we're going to divide x by x, we get 1. And between k and k plus 1, the integer part of x is simply k. So we can have I sub n equal the sum as k goes from 1 to n of the integral from k to k plus 1 of 1 minus k plus 1 half divided by x dx. We can now integrate, and we're going to get, after integrating, we're going to get the following. So now we just need to evaluate. As we evaluate, we get the following sum. So the sum as k goes from 1 to n of 1 minus k plus 1 half times natural log of k plus 1 plus k plus 1 half times natural log of k. Now the sum of all the 1's as k goes from 1 to n is simply n. And the sum, so we can rewrite it the following. So we can have n minus the sum as k goes from 1 to n of k plus 1 half times natural log of k plus 1 plus the sum as k goes from 2 to n, simply because log of 1 is equal to 0. Now we want to rewrite the first sum by replacing k plus 1 with k. If we do that, we're going to get the sum as k goes from 2 to n plus 1 of k minus 1 half times natural log of k. Now if we combine the two sums, we're going to have in equals n minus n plus 1 half times natural log of n plus 1 plus the sum as k goes from 2 to n of log of k. Now we have the sum of logarithms. Now the sum of logarithm is equal to the logarithm of products. And we're going to have the product of k's as k goes from 2 to n. And that's precisely the factorial of n. And then we're going to use the power rule on the second term. Okay, now we can take the limit. So if we take the limit, we can have the limit of this expression here. Now we're going to use Stirling's approximation to compute the limit. So we know that factorial n behaves like the square root of 2 pi times n times n divided by e to the n. So we're just going to replace that. Okay. Now notice how I wrote it. So I wrote it as square root of 2 pi times n to the n plus 1 half times e to the negative n. Now the natural log of e to the negative n is simply negative n. So that negative n is going to cancel with the first term there, which is n. N minus n is going to be 0. Okay, so we're going to have the limit as n tends to infinity of the natural log of square root of 2 pi minus the natural log of n plus 1 to the n plus 1 half divided by n to the n plus 1 half. Okay, so the second term can be written as natural log of 1 plus 1 half to the n plus 1 half. You can basically discard the 1 half constant. Now, if we take the limit of 1 plus 1 half to the n, we know that it's equal to e. So we're going to have natural log of square root of 2 pi minus natural log of e. Well, natural log of e is simply 1, so we get natural log of square root of 2 pi minus 1. And I think this is a good place to stop. Thank you for watching and see you next time. Bye.